said, I'll be talking about embarking on the cloud today, my experience learning cloud technology in a relatively short period of time. To give you a little introduction about me, like Al said, I'm a senior engineer in automation at Jumio Corporation. We're a KYC AML company dealing a lot with documents and things, and I try to automate the processing of documents through our systems. But I've been spending about 10 years building systems with Python, mostly on Linux, and all of it, nearly all of it, on bare metal servers. So that might make me a lot different than many of you who've been working with cloud. A lot of young people I know have been working with cloud all their career. I have virtually no cloud experience before 2020. In fact, started working with the cloud at the very beginning of the pandemic, which was great timing since I didn't have to touch computers anymore once that happened. But when you start with AWS and you never faced it before, you get kind of a rude introduction. This is the screen you see, and it's really intimidating and hard to make sense of that as a newbie. What do I even click on? How would I even know about any of these things? And to make matters worse, I think these days the SEO has made it so hard to find deeper, more meaningful articles. You can find easy tutorials pretty simply. You can find a blog post about how someone made everyone really happy by moving this one service to Lambda. You can find that pretty quickly, but the deep dives, they're harder to get to. And I found that frustrating and challenging for my Google foo. But fortunately, I have some learning experiences that while I'm not cloud-based, I've been able to fall back on and use and leverage in my transition to this environment. So what are those experiences? Well, they started out kind of rough. I'm a failed student, dropped out of school, a failed graphic designer. I'm colorblind. I have no idea why I chose that and even tried to go in that profession. I'm a failed musician, even though I think I'm good. No one else does. And a failed business founder. But through these experiences, I learned a lot of things, and one of them was how to code, and eventually use that skill to land working in a real code shop somewhere at a regional convenience store chain in Oklahoma. Now, I started like many of you had doing something very simple. In my case, writing reports for managers, the kind of thing where Janice from the Southwest Division needs a report knowing how many gift cards were sold in each one of her stores during X period. So query the SQL database, present it as a table, and be sure to provide the all-important export to CSV button, because someone's just going to take this out and export to Excel. This was the requirements I was given early on in my career, and boy, have times changed, but that's where I started. Unusually for convenience store chains in general, we had, among other things, offices, which I would kill for at this point in my life, but even though it was a weird gray trapezoid. But we also had a Linux-based infrastructure stack, and I had access to everything, though it was on my whole playground. And very unusually for a small regional convenience store chain, we had our own in-house point of sale development. And this is where I got to get my hands dirty doing real production code work on an interesting product. But that production code work was built on this tech stack, which, if you are fortunate enough to not know what Delphi is, in the 90s, there was a pattern of rapid application development where they would include form designers in your IDE, and you would just attach code that would control behavior related to these things. And that was the way you're supposed to build software. Well, it didn't work as well as people had hoped, and the environment wasn't great. And this particular piece of software had memory leaks, was difficult to change, that whole bit. Some of the same features that motivate many of us now to move away from monoliths towards microservice architectures. And that's an emergent thing, and we realized the same thing. So we started to tear little pieces out of it. We changed the communication model to TCP, and we're able to work in something that we actually liked, that resembles more like a modern architecture. We use Twisted, which is the OG async framework in Python, but otherwise kind of the same thing. Kind of a similar stack to what you might see in some microservice architectures today. And this served us well for many years, partly because this environment taught me about how operations work. I was not only a developer, I had to operate my software as well. And in this environment, support or the tech support help desk guys were tier one, and then we were tier two, and that was it. So when you work in an environment like that, everything gets automated because you don't want to deal with it or you can't deal with it. You don't have time. So we did configuration management ourselves, Puppet, that kind of thing. We had distributed, pretty much automated deployments. As soon as I pushed the button, things went to an app repo. Everything got installed. I got it out of the way. We made little maintenance consoles for our technicians to use to try and automate as much as we could, and let them handle as many problems as they could and not call us. And everything that we couldn't do, that we couldn't automate, had to be done by hand, and that's where the pain points were. When you had to do a database migration or really anything related to a database, I remember many times that transactions would get stuck in this weird database, and would have almost no idea how to fix it. Everything would crawl to a halt until we found a way to deal with it. This kind of makes me understand these days why people are willing to pay Amazon so much for RTS, because it can be a real nightmare to handle that kind of stuff in actual operations. First rollouts were always very difficult, but we had to be there on scene in many cases, plugging in hardware. And any miscellaneous snafus might end up with me actually driving somewhere and having to fix something. I remember very clearly a time when Puppet messed up the sudoers file in several of our computers, and had to drive around town, lay on the dirty check stand floors, trying to hack into our own machines in order to get them back under our control. You know, things you do back when you're actually working on bare metal. As far as development works, it was a two-person shop. Expectations are different for something like that. Code review was pretty much straightforward. The other guy looks at your code. When you develop, you just ask, you yell across the room, "Hey, are you using the lab?" Our development cycle, you do your own analysis, you do your own QA, and you better do your own QA, because if your software messes up, you're getting the call. And we did deployments when they're ready. There was a kind of a beautiful simplicity to it, but it taught me a lot about how to be the responsible software developer. Contrast that with my next gig, where I had to work with a much larger team, with a much less defined product situation, and it was pretty frustrating. Without having the challenge of production, people were going off in their own directions all the time, giving us all kinds of challenges and problems that again, larger software companies will often face: complex requirements, bad documentation, bad communication, software that was hard to run, hard to test, hard to even get a working dev environment where you can play with it and fix the problems you're handling it. Nobody had any idea how to package this thing to send it anywhere. And the constant branching and long running branches meant that there were always danger of major conflicts. And we had to try and merge them anyway, because some manager got inside of some feature that someone had developed way off by themselves. And that was the requirement, we had to merge it. So I knew these things had to change. The tech stack was a mess. It was chosen for reasons that made no sense whatsoever. Once again, it's time for a migration. But to what? I didn't know, but fortunately, there's a lot of research you can do on these things. These are in many cases problems to which there are existing solutions, and there's a good body of work that you can dive into and critically analyze in order to get solutions. Questions like, how do I package Python software? Still a difficult question in some cases, but there's enough information where you can go read several sources, critically evaluate them, and come to a solution that works for you. And for architecture reasons, you start learning that you can build abstractions around components to allow you to mess and play with implementations while you work all these details out, and not block the development of other people. And what we ended up with was something that was much easier to run, easier to develop, and easier to test. Because we use componentized architectures, because we use the dependency injection, which is just a fancy name for having parameters and passing parameters to components. Because we insisted on having rapid feedback at the local level for development, anything that you could run locally, we wanted to be able to run locally, so people were able to not get blocked by scarce resources, only having one camera from a particular vendor to work with, things like that. We wanted to simulate everything we could at all times to prevent the same thing, because you can get so much more done as long as if you can let people keep going and you break things into pieces. That allows you to design test points that have meaningful. You can get meaningful results out of a system without having to go through the whole thing every time. We came up with a decent tech stack, and I did a lot of this through communicating with people that I work with me. This is again very normal things you'll see in a Python tech stack today. That actually makes sense for the things. But had I not been curious and worked with the people worked well with the people I was with, we never would have considered something like Jupyter as an important part of our tech stack. But it wasn't. But in the cases that we're dealing with, it wasn't just for development. It was actually a feature that we were able to ship to customers to allow them to customize what we were doing as well. Now, going from this experience where we had kind of migrated something very complex and tangled to something that was a lot more organized, and even in the case of unclear requirements, I was really surprised when I came to my first full-on cloud experience, being tasked with finding better ways to develop and deploy ML, and running into thing as a very different kind of problem, services that are coupled to the production environment. That containers were being used as a high interest credit card to pass tech debt along the road. Development was so incredibly difficult because everything we did assumed some cloud service, being there at some point, that running things locally, everything had to be, that whole cloud environment had to be simulated in a local computer, making the development cycles very long, very frustrating, and very discouraging. And to add on top of all this, the production of large scale ML models is expensive and hard to coordinate. So my reaction to this situation was just, okay, I'll take on a serverless migration project to get rid of it because I know this is bad. And even though I know nothing about cloud, I guess this is the best way to learn it. And through this experience, I'm actually able to learn some meaningful things about cloud and share with these things all the way. What I learned on the way. And what I found is that while there are 200 or so Amazon products, there are a handful of basics things that everybody needs to learn, such as IAM, S3, the whole EC2 stack. Everybody needs to know it because it's such a ground level concept. You need to understand the difference between infrastructure as code, platform, infrastructure as a service, platform as a service, software as a service that Amazon provides, so you can kind of know what level of service you're working with, and knowing these kind of base components gives you a framework you can use to understand the rest of it. But beyond that, the offerings are too complex, so you have to pick something and just go with it. And I think that anybody that's working in a real project in a real company, that's what you'll do. So there's too many to learn. Pick one, try it. But all that being said, none of these things. It's important to remember that none of these things are commodities. That they're not just little pieces that once you understand them, you can pick up and learn. They are solutions that you have to tailor to the particular problem you're having within your own organization. So understanding how those things work together is as much a part of the process as just understanding AWS by itself is. And this process and the process of reflecting through this kind of made me think about what are the traits that allow us to learn, that allow us to pick up these kinds of things and apply them to real world situations. And what I came up with for these that I found in myself and others who I saw doing these things were a handful of things, one of which is curiosity. Curious people desire to ask questions and they look for answers. And this doesn't stop at a surface level. They're not satisfied with surface level expectations. In fact, I think curiosity could be described as a hunger or an insatiability for more knowledge, where there's a kind of a poverty in the stimulus that you get from weak explanations or surface level how-to tutorials that you might find, short blog post kinds of things. And this is a visceral and difficult to ignore sensation when experienced fully, that drives a lot of people in search of deeper and more meaningful answers. I mean, you see a lot of curiosity-driven behaviors in the workplace environment, and this is kind of what I see. I see people that look for general concepts behind specific behaviors, behind specific how-tos, behind specific things. They look for what's the general concept that I can use to navigate this environment. We like to joke about copy and pasting from Stack Overflow. Everyone does it, but I found in my career that one of the more valuable tools when copy and pasting is actually copying, pasting it on one side, and then retyping. And as I go through, evaluating each line of code, what does this mean? Why is this there? Asking those questions and forcing myself through that process is one of the better ways I found to learn new situations. Pouring through documentation is not the most fun thing in the world, especially because tech docs tend to be kind of dry, very dry kind of prose. But it's often where the nitty gritty details lie that we find the things that are important for our particular use case. What makes this work? What makes this not work? Seeking opinionated sources is critically important as well. Like I said, within things like documentation or summaries or how-tos, there's a poverty of stimulus. It should leave you hungry and looking for more. And that's one of the reasons you have to reach out to an opinionated source to get actual perspective on what's going on. And if you're lucky, you can find multiple opinions that may even disagree with each other. And that's when you really start to engage your critical thinking. You start to be able to see, okay, this person says I shouldn't use this for X reason, but this person says I should use it for a different reason. And you have to actually guess in your mind, what are those reasons? What are these things they're talking about? Even before you fully understand the product at play. That starts forming connections in your brain that you can continually use as you go along your project. It's important in this whole process as well to keep an open mind. That as you start reading opinions, as you start engaging in all this information, that you be willing to change in the face of new information that contradicts what you previously believed, and the ability to adapt in all cases. As well, curiosity shouldn't just be limited to technical or logical kinds of constraints. It applies to humans as well. Empathy in the workplace or in the distributed workplace, as the case may be, is an expression of curiosity. The human side in engineering often gets lost because we're so into the nuts and bolts and the bits and bytes. But humans make systems, and systems are always designed by a group of humans working together, and well, in most cases, multiple people working together. And Conway's law, if you know this, the principle that systems reflect the structures of communications of the organisms that make them, this drives all of our designs. So lack of understanding between different humans within an organization creates lack of understanding and barriers in systems. When people learn to talk to each other and communicate more directly, systems actually benefit from that. And so, like I said in the example with the ISP company I work for, learning to talk with other people on my team made me understand things that like using Jupyter, like a researcher's concerns and how they might differ from an engineer who spent time on the floor hacking into machines. How those different perspectives will be very informative in how we design the system we're working on together. And we need to be able to put ourselves in the other person's shoe to understand their requirements as much as our own, and understand where they may need to improve as well. Along with curiosity alone is not enough to really drive learning. We also need to be responsible. Being responsible is being answerable or accountable for the actions you take and having an investment in the consequences of your decisions. When I worked for the convenience store chain, I was responsible because I knew I was getting that call. That was a very visceral, direct form of responsibility. Most organizations aren't that simple, and you can't do things that way. And this is why and people try to avoid it. So this is why organizations try to find ways to encourage ownership. Much of what this is done is through a sort of sense of duty that people have, and it's conditioned by the culture around us. This is important that we remain responsible because untested knowledge is essentially meaningless. If you can be curious all day long and read all the books, ask all the questions, find interesting answers, and if you don't put it to the test, then you've had nothing. Very early on in my career, I loved to go through various web frameworks, as the case may be, PHP web frameworks actually, and I would try to break them down and rewrite them to be more cool and interesting, and I never ran them. And it's very clear in that simple example how useless something like that is. But to me, I was having fun. But I tried to apply that same principle to how I wrote code in the real world, and I got a very rude awakening. That doesn't work. You have to test everything you do before it goes out, and otherwise you face really serious problems. But because people don't want to always experience these negative consequences, they'll often set arbitrary limits within larger organizations to say, I'm not responsible beyond this point. I'm this kind of role in this company, and I go this far. And that's why people want to instill senses of collective ownership to try and fight this. That's why you have teams and things like that, because people feel a sense of duty to their colleagues. And that can often drive this sense of responsibility. It's very much social as much as it is tactile and personal. Responsibility also encourages rapid iterations, because if you know you have to test it, then testing in smaller increments will give you feedback much faster than having to wait for a long time. People will learn from knowing the pain of using long iterations to only find out that all their work has been in vain. This kind of responsibility encourages a lean experimentation that drives real results. The third trait that I think drives learning is one that might be a little odd, but I think it's really important, and it's laziness. And laziness is just desiring to not do the stuff you don't have to. And my choice of words there is very much intentional. I guess I could have said wisdom or efficiency, but I want this to be really visceral. This is the thing that makes you say no to nonsense. This is the thing that makes you say, I really don't want to do that. Because many people, they recognize, okay, that's inefficient. Okay, we could do that a better way. But there's a step between that recognition and saying, I don't want to do that. And that actually makes you actively challenge and fight the drudgery in your own lazy way. In fact, we used to celebrate this as a virtue of programmers. One thing that separates a good programmer from a mediocre programmer was a degree of laziness that made him seek out simpler and easier and less monotonous solutions to complex problems. These days, it seems to get diluted a little more. I don't hear this as much. I do hear things like the don't repeat yourself principle. That's a relatively weak statement. Most people know not to repeat themselves, and people pick up on that pretty quickly. But it's also not as full a statement of what a programmer needs or what an engineer needs to be doing to help make things more efficient. Don't repeat yourselves often apply to cookie cutter type operations, which can easily start reproducing junk or will fail as requirements and constraints change over time. Real laziness actually tries to find abstractions that give it power, and it refuses unnecessary work instead of saying, "Oh, I know that's unnecessary, but I'll get around to not doing it." It says, "I'm not going to do it," and by doing so, we're actually able to leverage the power of real entropy in finding scalable solutions. Finding a scalable Finding a scalable solution can be really hard, and it often comes from a place of inspiration more than it does from work. The work may lead to the inspiration, but that gets into cycles of rest and cycles of thinking that we find in people who learn really rapidly. But scalable solutions, when I'm talking about going from ON to O login to ON login, that kind of thing, making that leap. That's never just by trying harder. That's never just by I'm going to add more people to this project. That's by a real idea that someone really implements and tries a new way of doing that. And that often comes out of laziness. Laziness is also really important because we have this kind of cultural phenomenon that really comes out of responsibility in our organizations, where on the stuff on the left, nobody ever is going to get fired for these things. You don't get, no one ever has ever gotten fired for calling a meeting, even though everyone says we have too many meetings. No one ever gets punished for calling an individual meeting. But you can get fired for missing an important meeting. No one gets fired for working long hours, but you can get fired for not working long enough, even though working long hours can often be very inefficient. And so we need a force like laziness, a force that says, I don't want to do that much work. I don't want to work that hard, existing within ourselves and within our organizations to combat the slowly accreting nonsense that builds up over time. So to put these kinds of things all together, you can actually see different characteristics of learners if you combine these things. If you kind of combine these traits into one thing. If someone's just curious, if you have someone like this in your organization, they're a pain to deal with. They're going to be very anxious. They're going to have a lot of unapplied knowledge, and if they have even the slightest sense of responsibility about them, they'll feel really uncomfortable about it because they know it hasn't been tested. They know they can't get it to work. And that's why I call that this kind of person a false guru, is someone who's really invested a lot of the time and energy into thinking through problems, but never tried to test them. It's an unenviable place to be. Someone who's really responsible ends up being kind of a workhorse for the organization. They can only refine their skills are pretty limited within a certain area because they can't refine them beyond. They lack the vision to go beyond their own thing. And they often get pigeonholed as a result of this. If you're just lazy, then you're probably and have no other features, then you're either kind of a burnt out and you're not in the organization, or maybe you're a sociopath, but that's another story. When you start to combine into having two of these things, we see some more useful people who are actually curious and responsible at the same time. I think fit the kind of stereotype of the rock star engineer. They're solving problems like crazy, and they often forget to rest. They work 60, 80 hours a week. They solve all kinds of things. I think this can often be harmful to an organization more than people realize because again, they start to rely on these unscalable solutions, these bright stars, these individuals that solve lots and lots of problems without finding new ways, without being forced to find new ways to scale. In the case of lazy and responsible people, it's more of a workaday person someone who's made their terms with the work they do, and that's probably a generally well-adjusted person in many ways. Someone who's lazy and curious can act in a more philosophical role and be an advisor. Maybe their lack of responsibility might make them seem disjointed, but at least unlike the merely curious person, they won't have the kind of nervous energy that can pollute and spill over into other people. But if we put it all together and we have all these things in a single person or in a single organization, we get a really cool rapid learning cycle that I would describe as being an ingest, test, rest cycle. That we can consume lots and lots of information, we can put that to the test, and then we can give ourselves a chance to rest and reflect and let the unconscious mind work on these problems, and we can end up learning and going through things a lot faster than we would otherwise. And I find this to be a really effective way to rapidly learn new things in a confusing environment. So how would I apply these concepts specifically to the cloud? Well, I would say be curious. When you come across a tutorial or a how-to or a really simple thing like that, look deeper. Ask when something gets presented and you don't know what it is, ask questions about that. Google that thing. Follow up on these things. When AWS releases a new product or some vendor is selling you a new product, don't take the hype at face value. What are they? What is the person that's hyping this selling? Why are they selling it? Listen, it's okay to be sold things, but you have to evaluate these things on the merits and of the product and not the strength of the marketing. We should seek opinionated sources. about these things and critically evaluate them. With When you read Amazon's documentation and their product descriptions, you're never going to see them saying, "Hey, you should use this and not this," because that's an opinion oriented thing that they've chosen not to do as part of their strategy. But you can go outside of that and actually seek people saying, "Hey, you should do this, you should do that." And if you can read, especially things that disagree with each other, you are actually able in a better position to evaluate the reason, the decision points for choosing a particular technology or not for your case. To be responsible in these cloud decisions, it's really important not to count on untested assumptions. And this is probably more advice for managers than anybody, because in many or engineers too, in many cases the marketing material can make things seem a lot easier than they really are. But remember that most infrastructure is not a commodity. It's going to have to be tailored and fit. It's a solution that has to be tailored and work to fit your particular needs in this point in time. And you can only find that out by testing that in some meaningful way. And lastly, you need to be lazy. Be honest with yourself about labor and opportunity costs. If you're evaluating something and you say, "Oh, gee, that looks really expensive," always remember that you're comparing this with, "Oh, I could do this myself. I could do that." When you have to do something yourself, you have to think about what you're not doing as a result of that. And give yourself a break as well, because you can't learn it all. There's way too much stuff to do. You will have gaps in your knowledge, and that's okay. If you're dealing with teams that you need to onboard, one thing that I would suggest, and hopefully works for you, is to spend some time looking for quality courses that focus on not on walkthroughs and tutorials, and this is how you set up this thing, and this is how you use Cloud9 to do whatever. But that give you concepts that you can hang your hat on, that you can use to kind of form a map, gain a picture, an understanding of what the services that AWS has to offer. Let your devs play around and get them exposed to different opinions about how these things work. And then when they start to learn, give them a real challenge using one of these projects. Give them a real product they have to deliver on. Let them do a migration. You learn by applying that, what you learn, a lot more than you do just by reading a book. And then you have to be able to give people time to rest. Give them freedom to be a little lazy and experiment with things and go the extra mile reading some other place. Oftentimes when we take these kinds of projects, even experimental ones, we want to ask for estimates. We want to ask for when do you think this is going to be done? And people, in their sense of social responsibility, want to give a friendly answer. And really, in these cases, we need to be very, very careful about that, because people will put pressure on themselves that will starve them of the creativity they need to actually find better solutions. In some sense, you actually need to start fostering a bit of laziness within your own organization. Not without the other things too, importantly, but give yourself and give your organization a bit of a break to play around and experiment and find things that work, and then you'll be surprised at the solutions that arrive. Anyways, thank you all for your time. I think we'll do a little bit of Q&A. If you have time.
Josh, thank you so much. Just give me 1 second to check out the questions, and you do have some time for Q&A. Hold on one quick second. There's one question which I will just summarize. You mentioned that you're somewhat new to AWS. You started in 2020, and it's when you log in AWS, the number of services are daunting, 100 plus. We have a viewer which is interested to know how were you able to sort things out in a short period of time.
I wasn't. I went with one thing and kept going. Finding what's the main key parts of AWS is really through those opinionated sources. Like, find people who have opinions about AWS, and then use that as a launching pad to go to go find other things, and then you can start to piece together like what the meat of it is.
Mm-hmm. Any advice that you can give for folks that would like to embark on the same path on, let's say, early next year, where to start, where not to start?
I would say, like, get on. I don't really like Twitter, but I found Twitter really, really useful for this kind of thing, for like just getting, because people will have their hot takes, and a lot of them are dumb hot takes. But if you filter through that, you start finding really useful information and links to things that you would never get if you were just Googling, how do I do this on AWS? How do I do that on AWS? It takes a little more willingness to pursue like loose ends and rabbit. What's the right term? The metaphor escapes me, but yeah, just follow your gut on that. Don't always just stick to how do I do this now. Like, broaden your horizons a little bit.
Great. Josh, thank you so much for your insightful talk, and have a wonderful weekend. And thanks everyone else for joining.
Thank you.